Equations of parallel and perpendicular lines. So we all know that two lines are parallel, which kind of look like this. If this is one line and this is another line, right? So they are actually equidistant at each and every point from each other. Now the thing is, when it comes to their equation, we all know that the equation of a line is given by y equals mx plus b. So y equals mx plus b. Now, what is the slope of a line? Slope actually tells us the steepness of a line, right? How steep the line is. Okay, but if you look at the parallel lines, both of these lines are actually, they have the same level of steepness, right? So both of these lines are going to have the same slope. Okay, so if this line has a slope of m1, then this line will also have the slope m1, because both of them have same amount of steepness. And then what is b? B is your y-intercept. Y-intercept will be, obviously it's gonna be different. So if this is my y-axis, so we can see that the y-intercept for both of these lines is gonna be different. So if I talk about what will be the equations of two parallel lines, so we can write it in general form. Y equals m x plus b1 and y equals m times x plus b2. So this line will have the equation of this form and this line will have the equation of this form. The slope will be always same. So let's look at one example on Desmos. I'm going to go to Desmos. For example, let's take the example y equals 3x plus 5. And now let's keep the slope same, y equals 3x, and this time let's take the y-intercept minus 2. So you can see that these two lines are parallel, they have the same slope, but the y-intercept is different. In fact, you can actually plot infinite line with the same slope. All of these lines are gonna be parallel to each other. At 5, 9, y equals 3x minus 4. So all of these lines will be parallel to each other. It's just that their y-intercept is gonna keep changing. So this is about parallel lines. Now let's talk about the perpendicular line. Let's talk about perpendicular lines. Now the perpendicular lines have actually their slopes, slopes of perpendicular lines. I'm going to use a shorthand symbol for perpendicular, this one. So slopes of perpendicular lines is opposite. So they are opposite and reciprocal of each other. So what I mean by that is, if the slope of one line, so let's say I have line 1, here I have line 2, and both of these are perpendicular to each other, and if line 1 has the slope m1 and line 2 has the slope m2, then m1 and m2 will be opposite and they will be reciprocal of each other. So that means that if I will multiply, so first thing is that m1 is going to be negative of m2, okay, and m1 is also going to be reciprocal of m2. Okay, so the thing is, if I will multiply these two, if I will multiply m1 times m2, so then I'm gonna get negative 1. This is the most important part here. Okay, so let's do one example. For example, I have one equation, y equals 2x minus 1, and I have another line. So can you, first of all, can you tell me the equation of the line which will be perpendicular to this line? You don't have to tell the entire equation, but just the slope of the equation of this line. So I'm writing everything, y equals something times x plus 3. So what will be the slope of this line? So slope of, first of all, slope of my first line is 2. So this is 2. So slope of the second line is gonna be reciprocal of 2, that is 1 over 2, and it will be opposite, so multiply by negative. So this is gonna be the slope of the second line. So let's go to Desmos and plot these two equations. Y equals 2x minus 1 and y equals negative 1 over 2 plus 3. Something is not right. Oh, I'm sorry, my bad. Yeah. So now you can see, you can clearly see that these two lines are perpendicular. Okay, so remember that slope of the first line times the slope of the second line will give you negative 1 if the two lines are perpendicular.